right, for this lesson, we are going to apply congruence with triangles. So, you have some examples here of geometric figures that are congruent. On the left-hand side, you see 3 different figures. They're all the same size and shape, but they are twisted around on their axis. But that still means that they are congruent. With triangles, you do have to pay attention. They might look like they're congruent, but if they're different sizes or different shapes, then they're not going to be considered congruent. So when you're dealing with triangles, they will label all of the segments of a triangle. So if I have a triangle list right here, and this one, even though my drawings are imperfect, they're going to come across and tell you that this angle is congruent to this angle is congruent to this angle, and this one is congruent to this one. So that tells me that all of these angles are congruent, which means it's an equal angular triangle. If they also come through and say, this side is congruent to this side, this one's congruent to that side, and this one is congruent to this side, that's equal lateral sides, equal lateral congruence. And if all of that is congruent, then you can say that these 2 triangles are congruent. That's a hard word for me to say today. That makes sense? So the key is where they have marked the triangle. All right, so let's look at one. It's in your journals. All right, they have given you 2 triangles. They're all marked up. They want you to write a congruent statement for the triangles and then identify all pairs of congruent corresponding parts. So, it's actually easier to do that first. So I'm going to say corresponding angles. And then you guys tell me which angles are corresponding. So you just look at the marks. What do you think?
J and T.
Angle J is congruent, so you do the little equals with the squiggly line to angle T, because they have the 3 lines. What's the next pair?
R and L.
Angle R is congruent to angle L. And the last one is K and S, right?
Yeah.
All right, and then we have corresponding sides. So, again, we look at the markings. So we're going to say that JK segment is congruent to which one?
ST.
And then we can say that KL is congruent to SR. And the last one is LJ is congruent to RT. Now, because of that, are these 2 triangles congruent? Yes, because all angles and all sides are congruent. So when you tell me that, you just say triangle JKL. Now here's the trick. You have to list the vertices in the same order. So I started with J, meaning I started with the triple. So, and then single. So you gotta do the same thing when you label the other one. So it would be TSR. Does that make sense? I'm not probably gonna catch it or mark it wrong, but to be proper, you have to list them in the same order. Same thing when you're talking about the angles and sides. Okay, we have a statement and we have all the corresponding parts. Any questions? Awesome. Let's look at example 2. All right, so in this case, we have two shapes. The bend of my book makes the second shape look a little wonky, but they are telling you at the very beginning that DEFG is congruent to SPQR. So if it tells you that right at the beginning, what do we know about these two shapes?
They're congruent?
They're congruent, absolutely. However, one is spun, isn't it, compared to the other one? So like, which angle is Q the same as? F. So you do have to pay attention. If you were to take this shape and just spin it, 90 degrees, then it would look the same as the other one. Once you can visualize that, then you can solve for the different variables. So for A, they want us to solve for X. So let's find X. X is right there on Q. Can I make an equation? Since I know Q is equal to F, I can say 6y plus X equals 68, right? And then I can solve.
Wouldn't it be easier to put 2x minus 4 up against 12?
That's the other way you could do it.
So
The other equation, because you have just the x here, I was just looking at that, and the 12 here, those are congruent sides, so we can say 2x minus 4 equals 12. She's exactly right. See, in this one I have the y, so that would have been hard for me to solve. Good catch. So now we can solve for x very easily. We add the 4. We get 2x equals 16 divided by 2. So what does x equal?
8.
So x equals 8. That's for A. For B, it asks you to find the value of y. Well, we do know what x already equals, so now I can say 6y plus, what's x equal? 8 equals that 68 we were trying to do earlier. All right, so then we subtract 8. So y equals what? 10. So there's your two answers. A is x equals 8 and B is y equals 10. Any questions? Good. All right, let's look at example 3. We have a real life problem here. All right, this young lady is painting a wall in her bedroom. At least I assume that's a bedroom. If you divide the wall into orange and blue sections along the segment JK, will the sections of the wall be the same size and shape? Well, let's look. So we have KC is congruent to AJ. We have BC is congruent to AD, and we have JB congruent to DK. So far, so good, right? Now, this line is congruent to itself, right? So you don't have to say that it's congruent to anything else. So now let's look at our angles. C would be congruent to A. B is congruent to D. So now we just have to decide about angles 1, 2, 3, and 4. Well, what theorem talks about these? Do you remember?
Alternate interior.
Alternate interior theorem. What does the alternate interior theorems tell you about those angles?
Equal each other.
That they're congruent, absolutely. So then the reason would be by the alternate interior angle theorem. Angles 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So because of that, we can say that AJKD is congruent to CKJB. Make sense? All right, now let's look at another nifty theorem that makes things faster to solve. We have Theorem 4.3. This is called the third angles theorem. Basically, they're telling you if two angles, are congruent to two angles in another triangle, then that third angle is also congruent. This is kind of no duh. But can you tell me why?
Because, like, I don't know, something to do with all the angles adding up to one.
That's exactly it. If you know the measure of this angle and this angle, and you know the measure of this angle and this angle, then the third angle on both of these has to be the same, because no matter what, they all have to add up to 180 degrees. So, this seems like a silly theorem, but basically what it does is it solves turns 3 steps into 1 when you're trying to prove things. So, let's look at example 4. Just take a lot of pictures today. Is somebody at the door?
Oh.
Okay. I don't have my front office, so I hear things. Okay, so we have 2 triangles, and they're kind of sitting on top of each other. And they want you to find the measure of angle BDC. So BDC is right here. So they want you to find this angle. So if I were to draw this triangle not sitting on top of its buddy, they want to find this angle. In order to find that angle, we have to figure out the other 2 angles. So, can I tell what angle that one is congruent to? This is angle C. What angle is angle C congruent to?
D.
Angle D, absolutely. So that I know that the measure of this is what?
30.
30 degrees. Now, if I'm looking at the measure of angle B, which one is that one congruent to?
45.
45. So now can I find my third angle?
Mm-hmm.
Yeah, because I'm going to do 180 minus 45 minus 30. Or I could say 45 plus 30 and subtract them both. So that's 180 minus 75, right? Does that make it 105? Yeah, 80 minus 75 is 5, so 105. Okay. Now, if they ask you to tell you why, all you have to say is Theorem 4.3. They didn't ask you to explain it, but there's how you would. Awesome. Any questions there? Not too bad of a lesson so far, right? Example 5. We're going to skip. All right, so the last thing we need to look at is Theorem 4.4. All right, properties of congruent triangles. The properties of congruence that are true for segments and angles are also true for triangles. So all those theorems and properties you already learned for segments and angles, those count towards these triangles. So theorem 4.4 tells you the reflexive property of the congruent triangle is triangle ABC is congruent to ABC. So you can use that in your proofs. The symmetric property, if ABC is congruent to DEF, then you just flip them. DEF is congruent to ABC. That's reflexive. And the last one, this one's the trickiest, is the transitive property. If ABC is congruent to DEF, and DEF is congruent to JKL, then ABC is also congruent to JKL. Basically, you're taking out the middleman. Okay? Just a update on your theorems and proofs, so make sure you wrote that in your journals if you haven't already. All right, this is lesson 4.2. You are to do numbers 5 through 10. I think I gave you a pretty short assignment. I did. And 19 and 20. I bet you'll have this done before class is over. Let me see what time it is. Yeah, I think so.